So let's review what you've discussed before about light. And so when we're talking about light, what we're really talking about is energy that lies somewhere along the electromagnetic spectrum as shown in the slide here. And so this span is composed of several different forms of quote-unquote light, which we can refer to as gamma rays, infrared rays, the ultraviolet region, radio waves, and so on and so forth. And so when we think about this, we usually think about this in terms of energy, but also in terms of the wavelength of the light. And so just as a review, when we think about light, we most often think about it as a wave. And so let's remember kind of the general features of a wave. So this is a depiction of a wave. And so we have, for instance, with the function of sine of x. And so we can think of, we have the highest amplitudes of the wave we think of as peaks, and then the most negative amplitudes, if we kind of draw this through an x-axis, right, centered around an x-axis is the trough, all right? And so there are a few things we want to define. So as we discussed before, when we at the beginning about wavelength, right? So what exactly is the wavelength? So we can define the wavelength as the distance, right, in nanometers between each peak. Similarly, right, it should also be the distance between each trough, okay? So either way, we can get the wavelength, all right? And so this is defined as the distance from peak to peak or trough to trough, okay? And this has units most often in nanometers, although this may change to different units of distance depending on which region of the electromagnetic spectrum you're working in, okay? And then there are some other important definitions here. So one is the period. And so this is defined by the term tau. And this has units of time, commonly in seconds. And this is the time it takes, for the wave to move one wavelength. Lambda, right? Okay. Frequency. Takes this Greek letter nu, okay? And this has units of per second, right? This is number of periods per unit time. And you almost often see this in units of per second, which is also goes by the term of hertz. Okay, and then we have wave number, which is nu bar. And this we'll often see in units of per centimeter. Okay, that's the number of periods per unit distance. Instead of per unit time, okay? And so we can calculate between each of these. So for instance, wavelength, right, is equal to 1 over nu, right? The 1 over the wave number, I'm sorry. And then the frequency, nu, is equal to 1 over the period, tau. All right. Now, we can also interconvert between things that have units of distance, such as wavelength, which is in nanometers, and wave numbers, which are in per centimeter, and between units of time. And so that's because light travels, right? We can use the speed of light, c, because 2.99 8 times 10 to the 8th meters per second, right? And we can easily convert between each of these different parameters using this constant, okay? In addition, right, what we can do is that we can also convert to units of energy. And so the equation for energy is E energy in joules, so I want to put units there. E in units of energy equals H times the frequency, right? Or we can say H times the speed of light over the wavelength, either way, right? That'll get you the same thing, where H is Planck's constant. That's equal to 6.626 times 10 to the negative 34th joules times seconds. All right, and if we have frequency or wavelength, we can then convert to energy using Planck's constant and also the speed of light.